These are the Algebra 1 7.1 notes. So we're going to learn a lot about the basics of polynomials today. So a little bit of vocabulary and some, fairly easy math concepts. So we're going to start with the first thing, that is a monomial. Okay, so when we talk about a monomial, it is a number, a variable, or it can be a product of numbers and variables. So what that means is like 2xy to the third. It's like those are all multiplying. And then they have whole number exponents. So you cannot have something like x to the 3/4. That's not a whole number exponent. That, it exists and we'll learn about it in the future, but it's not a monomial. Okay, so when you're asked to find the degree of the monomial, it is the sum of the exponents of the variables of the monomial. So let's go ahead and take a look real quick at some examples here. All right, so this is a monomial. It's just the number 10. There's no variables. It has a degree of 0. So if there's no variable, degree of 0. This monomial is 3x, so it's a number multiplying times a variable. It has a degree of 1, and the reason why is x is like x to the 1. Remember, we learned that back in chapter 6. And so if there's no degree written there, it is x to the 1, and so there's 1 total there. Okay, look at this one. This says 1/2 ab squared. All right, a is to the 1 because it doesn't have an exponent written. And so remember that the degree is the sum of the exponents. So you add up the exponents and there's 3, so the degree is 3. Okay, look at what's not a monomial. So if there is a sum, adding or subtracting, okay, not a monomial. It's a polynomial, but it's not a monomial, okay? The word monomial is a single term. Look at the second one, 2 over n. The monomial can't have a variable in the denominator. The variable cannot be in the exponent. That would be exponential, but that's not a monomial. And the exponent cannot be negative. So it says it must have a whole number exponent. And it's definitely important to remember that whole numbers, okay? So when we're talking about whole numbers, they do not include negatives. Just the definition of a whole number is not a negative number. Starts at 0, 1, 2, 3, so on. All right, so let's try this. So this is a monomial. It's a single term. There's no adding or subtracting. And the degree is 2 because it is x squared. All right, look at this one. This one, you have x to the 1. Add the 1 in there if you need to. And so then you have a degree of 4 because you take the 1 plus 3. And so your degree is 4. All right, on this one, you have 3 plus 3 is 6. Now, this is a constant because there's no variable, so that's called a constant. And remember that constants have a degree of 0. All right, on E, x to the 5th, y to the 1st, go ahead and write the 1 down, z to the 3rd. You add all those up and you get 9. So it has a degree of 9. Okay, so that's specifically a monomial. Let's learn some more. A polynomial, poly means multiple, is a monomial or sometimes a sum of monomials. So it can be like adding or subtracting. So every single monomial is called a term of the polynomial. So if you have a binomial, think about a bicycle with 2 wheels. It has 2 terms. So for example, like 2x plus 3. There's 2 terms there. Or x squared minus 5x. There's 2 terms there. Okay, so a trinomial, think about a tricycle with 3 wheels. So to me, it makes sense that a trinomial has 3 terms. So as an example, x squared minus 7x plus 1. There's 3 terms there. That's a trinomial. All right, so a polynomial functions a little bit differently from a monomial. You don't add up the exponents. So when they ask you for the degree of a polynomial, not a monomial, when it's a degree of a polynomial, then you take the greatest degree of its terms. All right, we'll see that in just a minute in this example. Now they will also ask us to write it in standard form. In standard form is when the polynomial is written where the exponents of the terms decrease from left to right. So you don't have to write this down. Let me just show you an example real quick. If you had x cubed minus 4x squared plus 3, do you see how the degrees, the exponents go 3 and then 2 and then to the constant? That's standard form. So if you had something like x minus 7x to the 8th plus 5x squared, that's not in standard form. Do you see how they're not going from the highest power down to the lowest power? So we'll see that more in examples. You don't have to write that down. When a polynomial is written in standard form, the coefficient, remember a coefficient is the number in front of the variable. So the coefficient of the first term, the one with the highest power, is specifically called the leading coefficient. Okay, and the constant is the number without a variable. So it doesn't have a variable, that means it doesn't change. So that's why it's the constant. Okay, let's see all of this together. So it says, write this equation, so here's our equation right here, here's our polynomial, in standard form. So standard form is from the highest power down. So the highest power here is 4, so we're going to start with this term. It's not just x to the 4th, this negative in front comes with it. So it's negative x to the 4th. Now the next one would be x cubed and then x squared, but I don't see either of those. So next up is this 15x. Notice it's positive, so put plus 15x, and then plus 6. That's standard form. It goes from the highest power on down and ends with the constant. Okay, so this has 3 terms, and that tells me it is a trinomial. The degree, remember, when it's a polynomial, you do not add them up. And remember, a polynomial is where you're adding or subtracting the terms. So don't add them up. The degree is just the highest power. So the highest power is 4. So it's a degree of 4. The constant is the number without a variable. The constant is 6. And then remember, the leading coefficient is the coefficient of the first term. So when it's in standard form, look at the rearranged version. The coefficient, the number in front of x to the 4th, there's a negative there, but it's actually a negative 1. So remember that when you have a negative x to the 4th, that's like a negative 1x to the 4th. So negative 1 is the leading coefficient. Okay, so let's go ahead and let's do this practice with several of these. All right, so here's just a chart. So this top up here, negative 3z to the 4th, this is the polynomial. It happens to also be a monomial in this case. It is already in standard form because there's just the one term, so you can't rearrange it. Its degree is 4, meaning its highest power. The leading coefficient, so this is the leading term, meaning the one with the highest power. Its coefficient is negative 3. There is one term, meaning it is a monomial. And the constant here, it does not have a constant. Okay, let's try another one. So we're rearranging this. The term with the highest power is 5x squared, and it's positive, so that goes first. So 5x squared, then the minus x, then the plus 4. All right, its degree is its highest power, which is 2. The leading coefficient, so remember, look at the rearranged version, the leading coefficient here is 5. It has 3 terms, which means it is named a trinomial. And then its constant, the number without a variable, is 4. Okay, pause the video and answer these next 2 columns. I will pause my video and fill in the answers. So pause it, answer them, and then press play, and you can see the correct answers and fix it. Okay, so go ahead and check your answer here as needed. All right, so that was kind of heavier on the vocabulary. And so now if we go ahead and we look at this example 4 is finding the sum. So finding the sum is fairly easy to do. You basically are combining like terms. So I like to go in order, that way my answer already ends up in standard form and I don't have an extra step at the end. So looking through here, the highest power is this 2x to the 3rd plus x to the 3rd. 2x to the 3rd plus x to the 3rd makes 3x to the 3rd. Now do your x squareds. So here is negative 5x squared plus 2x squared. Negative 5 plus 2 is negative 3x squared. Then do your x's. There's only this one x right here, and there's no other x, so just plus x. And then your constant, minus 1. And then your answer is already in standard form, so you don't have to rearrange it. Okay, check this one out. So the highest power is x squared. So 3x squared plus x squared, that's 4x squared. X plus 4x is 5x. And then negative 6 plus 10, those can combine, and then you get 4. So when you're combining like terms, you're looking for they have to have the same variable with the same exponent to be combined. All right, and so subtracting is just barely different. You start with the first parentheses. I'm just going to write it down. I don't change anything. Now, when you subtract, you're subtracting all of this. So you have to distribute your subtraction. So essentially, you're distributing the negative. So when you subtract a negative, that changes to adding 2n squared. Then subtract 2n. And then subtract negative 4 changes to adding 4. So it basically changes all the signs in that second parentheses. Now you can just combine like terms. So we get 6n squared, and then minus 2n, and then 5 plus 4 is 9. You can tell I underlined them. That's just so I don't lose anything, have anything left behind. Sometimes you can use like a highlighter and like highlight them in different colors to show what needs combined. Do a method that works for you. All right, so I'm subtracting this parentheses, so I'm going to subtract the 3x, 3x squared, so it changes to minus 3x squared. Subtracting negative x changes to adding x. Subtracting a negative 8 changes to adding 8. And then from there, I start with my highest power. 4x squared minus 3x squared leaves 1x squared. You typically don't write the 1. Negative 3x plus x is negative 2x. And then 5 plus 8 is 13. And that's my answer. And by doing it really methodically, it ends up in standard form, which is super nice. Okay, so look at this word problem. It says there's a red balloon, that's the top one. It's thrown straight down from a height of 200. That's the 200 right here. And then at the same time, a blue balloon is dropped from 100. So there's slightly different equations. This equation is longer because it involves force, because it was thrown versus just being dropped and letting gravity take it. Now, it says that t is how many seconds since they were released. Write a polynomial that represents the distance between the water balloons after t seconds. So you're taking the red balloon's height minus the blue balloon's height. So the red is this negative 16t squared minus 40t plus 200. And you're subtracting the blue, which is this equation. So really, it's just like a problem we just did. So keep in mind, make this bigger for you, that you start with the first parentheses and you distribute your negative to the second parentheses. So you're going to add 16t squared and then subtract 100. It changes all the signs. So the 16t squareds will cancel out because negative 16t squared plus 16t squared makes 0. Then you still have negative 40t, and then 200 minus 100 is 100. All right, so the distance between the two balloons equals this equation. So real quick, it says interpret any coefficients. Okay, the 100, the constant is 100. And so 100 represents the distance they are apart when this problem begins. Let's see, beginning distance. All right, so like it started at 200, the other one at 100, they were 100 feet apart. And then the negative 40 means that the distance between the balloons decreases 40 feet every 1 second. So the red balloon is being thrown, so it's accelerating, so they're actually getting closer and closer. So every 1 second, the balloons are 40 feet closer to each other.